Okay, so we've looked at factoring with GCF. So our next step and the main portion of factoring is this factoring when it is an ax squared plus bx plus c. And we have a couple methods or organizational tools to help us with that. One is what I call Xbox, the other is grouping. So I'll work through both of those for you. So our essential question is, how can ax squared plus bx plus c be factored? So we're going to start by using Xbox. So our a and c go on top being multiplied together, and then our b just goes on the bottom. And here we look for terms that multiply to give us AC and add to give us B. And then what we'd get here is you get ax squared, c goes there, and then what we found here goes there with an x. So let's look at 1a here. So my a and c multiply together, 3 times 15 is 45, and then 14 goes on bottom. So what things multiply to 45 and add to 14? If you're stuck, you can start writing stuff out. So all the factors of 45, 1 and 45, well, those don't add to 14. 2 doesn't work. 3 and 15, well, that adds to 18, so that doesn't work. 4 doesn't go into 45. 5 goes into 45. So 5 and 9 multiplies to 45 and adds to 14. So we get 5 and 9. So up here we get 3x squared. Here we get 15. And then we get 5x there and 9x there. It does not matter which one you put of those two. And then what we're looking for is, as we go this way, what's my GCF between 5x and 15? Well, that's 5. What is my GCF of 3x squared and 9x? Well, they both have a 3 in common and an x. Then we go up. What is my GCF between 3x squared and x? Well, the numbers don't have anything in common, but they do have an x. And then 9x and 15, well, there is no x in common, but 9 and 15 have a 3 in common. So then this factored out becomes 3x plus 5 and x plus 3. Now again, we're undoing what we did when we multiplied. So previously, we had problems that look like that, and we'd distribute, and that would give us a 3x squared plus 9x plus 5x and then plus 15. So you can kind of see where those 9x comes from, where that 5x comes from. Then when we'd add those like terms, 9 plus 5 is our 14, and that would put us back into that original problem. All right, let's look at 2a now. So our a is 2, and our c is negative 9, so now we get a negative 18, and then our b is 7. So what are the things that multiply to 18? So 1 and 18, but now we're looking for a difference since that is negative. So 1 minus 18 is 17, that doesn't work. Let's go 2 and 9. 2 times 9 is 18, and then 9 minus 2 is 7, so that does work. So we have positive 9 and a negative 2. So we get 2x squared here. We get negative 9 there. We get 9x here and negative 2x here. Now another way, instead of looking for the GCF, some of you guys might feel more comfortable with, is coming up with what are things that multiply to each of these. So here, let's say I get a 2x and then an x. And then as I look at this, what times x gives me 9x? Well, that has to be 9. What times 2x gives me a negative 2x? Well, that has to be a negative 1. And then check negative 1 times 9 is negative 9. So that would work. So we get 2x plus 9, and then x minus 1. Now, showing this with the GCF, how that'll work. So I look here. Well, what do they have in common? They have a 9 in common. What do those have in common? They have a 2 and an x. Going this way, 2 and 9 have nothing in common, but they have an x in common. And then going this way, well, you'd say they'd have nothing in common, but they always have at least a 1. Now this one's a little easier because they both have a negative, but let's say they don't. We can double check. 2x times 1 is positive 2x, but I need it to be a negative, so I'm going to make that 1 a negative. Negative 1 times 9 gives me negative 9. All right, so then that works too, so we're good with that. All right, so let's look at those same problems using factor by grouping. So we are still going to use our x. And I get 45 on top, 14 on bottom, just like we did on 1a. And we already know we get 5 and 9. So then what happens is we still have our 3x squared. But now our 14 is made up of those two terms, like we saw up here when we multiplied it out. So then I get a plus 9x plus a 5x and then plus 15. And then we group it. So I look at the first two and then the second two. And I bring in the sign on that second group. So here, 3x squared and 9x, we're just looking for the GCF now. So that's going to be a 3x. And that leaves me with an x plus 3. And then on the second one, 5x and 15, looking for GCF. Well, my GCF there is 5, and that's positive. So I pull out a positive 5, and we're left with x plus 3. And then we can see here that we have an x plus 3 and x plus 3. So I pull that out. And then that leaves me with the 3x. And then a plus 5. All right, so let's do 2b now. Again, starting from scratch, we draw our x. We'd get negative 18. And then 7, as we saw, that is positive 9 and negative 2. So that gives us 2x squared. That 7 now is made up of 9x and negative 2x. And then we have that negative 9. Factor. Bring that second sign in. So what do 2 and 9 have in common? Nothing, but they do have an x. So I factor on x. And I'm left with 2x plus 9 in that first term. In our second one, they have nothing in common. But we do have a 1, and it is a negative 1 because of that. And that leaves us with a positive 2x and a positive 9. Now that's good because we get 2x plus 9 and 2x plus 9 in common. And from the first, we're left with an x. And from the second, we're left with a negative 1. All right, so you can do any method on these, whether you're someone who likes Xbox or you like grouping. Either one works. So let's take a look at 3. I'll do it with a Xbox here. So now our A in this case is 1. And our C is 24. So we get 1 times 24, which is just 24. And then our B is 10. So things that multiply to 24, 1 and 24 we already saw, that doesn't add to 10. What about 2 and 12? And that adds to 14. 3 and 8. Well, that adds to 11. We're getting closer. 4, and 6. That adds 10, so that works. Then we draw our box. And I have x squared, and 24, and then 4, and 6x. Look for our GCF. So 6x and 24, we get 6. X squared and 4x, we get x. 6x and x squared, we get x. And 24 and 4, we get 4. So then this factored would be x plus 6 times x plus 4. All right, now from the beginning, I've neglected a step. And so as we look at number 4, and then down over here, our steps for factoring, our very first thing we should always check for is a GCF. Now, all the previous ones are GCF or 1, but we do need to get in the habit of checking for GCF. So as we look at number 4, is there a GCF between those three terms? Well, they don't have an x, but 5 goes into 5, 5 goes into 10, and 5 goes into 35. So we have a GCF of 5. And that leaves us with 5, and we get x squared minus 2x minus 7. And as I'd said on the previous lesson of factoring a GCF, we would get to the point where we'd factor that out, which we will do now. Now my a is 1. My c is a -7, so we get -7 there. My b is a -2. So then we look, is there anything that multiplies to -7? Well, it's just 1 and -7. Well, that doesn't do anything for us because that doesn't add to -2. So then that would be the answer there. If that were factorable, you'd factor it, and you might get something that would look like that. Okay, but I want to emphasize, since we did factor out a GCF, this was factorable. All right, so our steps for factoring, hugely important is this first one. Check for a GCF. If there is a GCF, you did factor it, so it was factorable. Once we go from there, you may be left with a trinomial or something that is factorable, and then what we're going to do at this point is we have X box or grouping, both the same process, just whatever one you feel most comfortable with. All right, so as we look at some more factoring here, we want to factor each expression by any method. So since 5 and 6 are already X box drawn, I'll do those that way. So we want to check for a GCF. So I'm going to write that here. No, I'll write it off to the side. So our GCF for this one, they don't have an X in common, they don't have a number in common, so our GCF is 1, which doesn't change anything about this. So our A is 1, our C is -5, or -15, sorry. So that gives us -15 on top. That gives us a 2 on bottom. Now we're looking for a difference, so I know one's going to be positive and one's going to be negative because that is negative. So things that multiply to 15 and add to 2. Let's go 5 and 3. So I get x squared minus 15 positive 5x and a -3x. Then our GCF, so that is 5 there. That is x there. That is x there. And then here we get a 3. And then double check x times 3 is +3, but I need a negative. And then -3 times 5 is a -15, so that works. So then this factored out is x plus 5 and x minus 3. Okay, so let's look at 6 now. So is there a GCF? It looks like a 3 can go into all of them. And then so that leaves me with 3x squared minus 10x plus 25. So then our A is now 1. Our C is 25 because we're using that new one. So this one goes away and we're now using this here. So that's 25 on top. And then our B is a negative 10. So as we check that, since this is positive, we know both these signs are the same, and that's negative, so those are going to be negative. And multiply to 25 and add to negative 10 is a negative 5 and negative 5. Now I'm again just dealing with this, so I get x squared and 25 here. Negative 5x squared, negative 5x squared. Or sorry, not x squared, just x. Factor out, that gives me a 5. Factor out, that gives me an x. We go this way, that gives me an x. And then we go this way, that gives me 5. Now as we double check, x times x is x squared, that's good. X times 5 is positive 5, but we need negative, so I'm going to make this a negative 5. And then negative 5 times 5 is negative 25, so I need to make that one negative. X times negative 5 is negative 5x there, so we're good. So make sure we double check, especially when there's negatives. Those negatives will end up out there, but double checking always works. So then we get x minus 5, x minus 5. And if we left it at this, we'd actually lose a point even though we did all the work. Do not forget that GCF. So then the fully factored answer would be 3x minus 5 times x minus 5. All right, let's look at 7. So then my A is 7, my C is negative 8, so that's a negative 56, and then my B is a negative 26. And so as we look for factors, and then since I know that this is negative, these are going to be opposite, so I'm looking for the difference. So I have 1 and 56. Well, that's a difference of 55. That doesn't work. I have 2 and 28. It's a difference of 26, so that works. And I want negative 26, so negative 28 is going to go there. 2 is going to go there. And then as we do our grouping, we get 7x squared plus 2x minus 28x minus 8. Then we group. Here we have just an x in common. That leaves us with 7x plus 2. Here we have that negative that we're going to pull out. And then we have a 4 in common. And that leaves us with 7x plus 2. Then we have 7x plus 2 in common. So I pull that out. And we're left with an x. And then a minus 4. All right, let's look at number 8. And so our GCF, which I forgot to do on the number 7. So our GCF on number 7, as we look at this one, is just going to be 1 because x's aren't in common. Nothing goes into 7, 26, and 8. So as we look at 8, we have a GCF of 2. So that now gives us a 2y squared plus 7y plus 3. And then this will factor. My A is 2, my C is 3, so that is 6. My B is 7. Multiplies to 6 and adds to 7 is 1 and 6. So then we get 2y squared plus 1y plus 6y plus 3. And then group. Here we have just a y in common, so that gives us 2y plus 1. Here we have a 2 in common. Oh, sorry, not a 2. A 3 in common. That gives us 2y plus 1. There's our 2 y's that are in common, so we can factor that out. And then we're left with y plus 3. All right, your turn to do 9 through 12 there. Work on those. We'll discuss those when we come into class. All right, now this definition of prime means it's in its simplest terms, and it is unfactorable. Okay, that includes GCF, Xbox grouping. We can't do any factoring to that. So as we look at 13, our GCF is 1, which doesn't do anything, so that is still unfactorable. And then let's look at our X. So A is 1, C is -8, B is -4. Is there anything that multiplies to -8? Well, we have 1 and 8. We're looking for a difference. Well, that's 7. We have 2 and 4. Well, that's 2. 3 doesn't go into it, and then once we get to 4, that goes to 2, so it doesn't matter. So then this one is what we would call prime. The only thing it had in common was a 1. We couldn't Xbox or group it, so then that one is called prime, meaning it's unfactorable. All right, let's look at 14. Hey, is there a GCF? Always our first step. So is there a number that goes into 6, 26, and 10? There is. It is 2. That leaves us with 3x squared plus 13x minus 5. Now, if we're just looking to see if it is prime at this point, we factor out a GCF, so it is no longer prime. If we wanted, we could go ahead and factor this further. So 3 times -5 is a -15, and then we get 13 here. Since this is negative and this is positive, and we're looking for a negative and a positive, my biggest is positive, so for 15, we have 1 and 15. Well, that has a difference of 14. That doesn't work. And then 3 and 5, that has a difference of 2. That doesn't work. So there is nothing. So then this ends up being our answer, which is factorable because we factored out a GCF of 2. All right, you have your quizzes, and then our essential question of how can ax squared plus bx plus c be factored.